Hello, I'm back. Kepotong. Ah, oke, jadi kita bakal lanjut belajar. Tadi kita sampai, nih. Semoga subtitlenya udah bisa. Amin. I hope the subtitle is ready. This is what This is for
All right, it's time for the final project of the module, and we are going to be building a secrets project, which is going to be a client-side website that uses the secrets API in order to reveal the deepest, darkest secrets of people anonymously. This is inspired by a...
Sejak kapan bermasalah ya? Subtitlenya ini loh. Dari kemarin loh. Perasaan kemarin aman-aman aja.
In the last lesson, we created a very basic Node application, and all our application did was file system. So that could be local on your computer, or in the case of your web application, it will be onto the server computer, as well as things such as...
Astaga, terus aku harus pakai apa ya? Saya pakai Microsoft Edge anjir. Kenapa ya?
networking in order to reach across the internet and carry out certain bits of functionality that's important for the back end of a web app, and a lot more. Essentially, you can think of these native modules as kind of like the games that come pre-bundled with your operating system. One of my favorite is Minesweeper on Windows. It's sort of endlessly entertaining, and I don't really know why. But also remember there was Pinball and Hearts and Solitaire, and you can of course install more games onto your computer, but the native ones are
Nggak mau sih.
you can think of these native modules as kind of like the games that come pre-bundled with your operating system. One of my favorite is Minesweeper on Windows. It's sort of endlessly entertaining, and I don't really know why. But also remember there was Pinball and Hearts and Solitaire, and you can of course install more games onto your computer, but the native ones are the ones that came pre-bundled. Because they thought maybe they'd be useful.
Wah, ini akunnya kayaknya, Cok. Apa yang pencet ya Allah, ya Allah.
Are the ones that came.
Aku pencet apa sih sampai nggak mau?
game pre-bundled because they thought maybe they'd be useful to.
Kenapa gitu sih? Ngelag, saya ngelag. Kenapa ya? Mau lagi. Sebenarnya ini kenapa sih? Padahal jalan aku harusnya nggak ngocok. Harusnya nggak nyala. Ini webnya emang lagi error atau kenapa sih? Astaga. Lagi error ya web Udemy. Orang mau belajar loh. Ah, bikin kesel aja. Kemana sih subtitlenya?
Entertain you or.
Mbak. Sumpah lah, aduh, tai, orang mau belajar juga. Terus aku nonton di HP lagi, anjir. Sakit mata nonton di HP itu, cok. Ganggu orang belajar aja, cok. Eh,
anonymously. And it's weirdly fascinating to read through people's secrets and what they reveal to us when they don't need to be identified. And in order to do this, we're going to be using the Secrets API. All right, it's time for the final project of the module, and we are going to be building a secrets project, which is going to be a client-side website that uses project, which is going to be a client-side website that uses the Secrets API in order to reveal the deepest, darkest secrets of people anonymously. This is inspired by a real app called Whisper that was pretty famous a few years back. And essentially, it's people anonymously. This is inspired by a real app called Whisper that was pretty famous a few years back. And essentially, it's people across the internet sharing their secrets anonymously. And it's weirdly fascinating to read through people's secrets and what they reveal to us when they don't need to be identified. And in order to do this, we're going to be using the Secrets API and getting hold of random secrets using Axios, so that we can put some of the different pieces of information that we've learned over the different modules together to create a real product. Go ahead and download modules so that we can put some of the different random secrets using Axios, so that we can put some of the different pieces of information that we've learned over the different modules together to create a real product. Go ahead and download the Secrets Project zip file, extract it, and open it inside VS Code. As always, the first thing to do is to cd over to this location in the terminal, run the npm I command in order to install all the node modules, and then we can preview what this website looks like by using nodemon to run the solution.js. Once you load up this website, it's not called Whisper, it's called Lisper, you'll see that we've got some fancy styling done in CSS. We've got the username of the person who submitted this secret, and when we hover over the card, we see their secrets revealed. I'm keeping this project relatively simple because we've had a long module, and I just want you to be able to practice some of the previous things we learned using EJS and also using Express. We're just going to hit up the random endpoint for the Secrets API. And if you wanted to, you could refresh the website and it would load up a different random secret. So the first thing I want you to do is to take a look at the index.ejs and see the structure of the different variables that are being injected in here. So the user corresponds to this part and the secret corresponds to the part that shows up. Don't worry about the styling, it's already created for you in the main.css. Of course, as always, if you wish, you can remove all the styling in here and create it yourself from scratch as well. You don't have to use anything that's provided, although I recommend it because we're focusing on skills that we want to practice. And there's always capstone projects for you to fully customize and create your own projects from scratch. In the index.js, I've got a number of hints for you. And again, you could delete all of this and just go off the functionality that you see when you run solution.js. But these hints show you all the steps you need to go through in order to make this work. Now, we're not doing anything too fancy in here. We're not doing authentication. We're not using bearer tokens. We're not doing registration. I just wanted to keep this simple so that we focus on the things that we really care about, which is how do you work with an external API? How do you use the documentation of the API? And how do you use Axios and Express to hit up that API and grab the necessary pieces of data to populate a client-side website and consume data from that API. This is a really common skill and just wanted to give that one last bit of practice and create a project that's pretty cool that you can share with your friends and family. Once you're ready, go ahead, pause the video and give this project a go.
Ngantuk bang. Baru mulai langsung ngantuk ya. Baru mulai langsung ngantuk. Ya maaf. Masalah nggak ada subtitle, cok. Aku takut ada yang sesuatu yang kelewat. Mana? Cara statik gimana ya? Lupa aku. Cara statik itu express.static. Kayak gitu kan.
All right, let's run through the solution together. First things first, let's go ahead and import Express from the Express module that we have already installed. And you can check that by going to package.json, looking at the dependencies. And then the next thing is we're going to also import the Axios module. And then we can move on to step 2. We're going to create a new app from the Express module like this. And we can set our port to our normal port, which is 3000. In this step, we're saying use the public folder for static files. And if you don't remember why we're doing this, it's because we have images that are being used in the front end of the website. But more importantly, we've also got our style sheets that live in a folder that we can keep static. And if you don't remember this, we did this when we first learned about using Express to create servers. And this is an important middleware. So we do app.use. And then in the Express package, there is something called static, which is a built-in middleware function and allows us to serve static files and allows us to specify which folder contains the static files, which in our case, as you can see, is called public. Now, what this means is that any static files that are being used will be able to refer to public and then can add the relative path after that location. So it's public styles main.css. Now, step 4 is when the user goes to the homepage, it should render the index.ejs file. So this is our app.get. So when the user goes to the home page, so the /, we're going to have our rec and res, our anonymous function here. And inside this function, we are going to return something by using res.render. And what we want to render is index.ejs. And the next step is we should be able to use Axios inside this get route to get a random secret and pass it to EJS to display the secret. Here, we're going to create our constant called result, and it is going to be as a result of calling axios.get. Now we're going to provide the URL of the route that we want to hit up, which is the random route. And you can split this up to base URL, you can add it as a config, but in my case, I'm just going to add it in here straight up as it is. Remember, this method is asynchronous, and you can see that when you hover over the .get, you can see that it returns a promise. That means in order to get hold of the result, we either have to get hold of it by chaining .then at the end of this method call, or we change this to an asynchronous function and use await before we call this method. So that means we're waiting for this to give us the result, to be able to put it into this constant before we continue to the next line. What's going to happen in the next line is we're going to pass over some data to our index.ejs. And that data is going to come from the result. And we can take a look at what kind of result we get. So this is the response that we would get through result.data. And we can get hold of the ID, the secret, the mscore, the username. So in our case, we only want the username and the secret. So let's remember what the keys for those pieces of data are. And then we're going to take a look inside index.ejs, see which variables we need to hit up. So there's one called secret and one called user. So let's set that up. Secret : this is the first piece. And then the other one is called user. But if we look at the keys that we get back from the API, the first one is indeed called secret. So it'll be stored under result.data. And then here is where we add that key, .secret. And user will be result.data.username. So that matches with what we get back here. Now, you can, of course, simply just log result.data in order to see what you get back and to be able to format this. And you can also, through trial and error, hopefully see whether if these pieces of data are being passed to the correct parts of your HTML. But hopefully this will work. And if not, we will add a try and catch block in order to make sure that we catch any errors. We put the part we want to try inside the try block, and inside the catch block, we're going to send the status of 500 because something went wrong in our server, and we are going to console log any errors by writing console log, and we can grab hold of the error here, and it is error.response.data that contains any messages from the API so that we as the developers can look into this and try to solve any problems. Now, for the user who's looking at our website, they won't know what to do with that. So we're just going to show a error code that says something's wrong with the server. Don't worry about it. And we can debug this from our developer side. Finally, all we need to do is to run app.listen in order to listen on the port that we've specified. And as usual, we're going to add an anonymous function that console logs to the terminal that says server started on port, and then the port is the port number that we put up here. That's all we needed to do. And now if we go ahead and run this, so stop anything else that's running, use nodemon to run the index.js that you just created, go over to localhost 3000, and hopefully you will see the username load up here. You will be able to see their secret when you hover over the card. Did you manage to get this to work? Did you manage to use what you've learned so far in the module? Feel free to modify this project as you wish or change it up, do anything you like to extend its functionality, but just be aware that because it's resting on the Secrets API, which, as we mentioned, is an API for students to learn and not something for a production app, that all user submitted data, including their registration, so their username, their password, any tokens, any bearer tokens, any usernames, any secrets, are erased pretty much on a regular basis, like every 24 hours or 48 hours. So it's not going to be a real API that you can rely on to create a real product. But in the next module, where we have a capstone project coming up, I'm going to show you lots of real world APIs that you can use to create your own project that are more robust and are suited for real world projects that you can build and add to your portfolio, or even create a startup or a product for yourself. This could be the beginning of something wonderful. I hope you enjoyed this module with me, and I'll see you in the next one. Hey, it's Angela here again. And of course, extend its functionality, but just be aware that because it's resting on the Secrets API, which, as we mentioned, is an API for students to learn and not something for a production app, that all user submitted data, including their registration, so their username, their password, any tokens, any bearer tokens, any usernames, any secrets, are erased pretty much on a regular basis, like every 24 hours or 48 hours. So it's not going to be a real API that you can rely on to create a real product. But in the next module, where we have a capstone project coming up, I'm going to show you lots of real world APIs that you can use to create your own project that are more robust and are suited for real world projects that you can build and add to your portfolio, or even create a startup or a product for yourself. This could be the beginning of something wonderful. I hope you enjoyed this module with me, and I'll see you in the next one. Hey, it's Angela here again. And of course, I'm here to congratulate you on completing yet another module. If you keep showing up like this, and if you keep... Hey guys, in the previous lessons, we learned all about application programming interfaces, otherwise known as APIs. In this module, we're going to learn how to build our own APIs from scratch so that you can get a good overview of the entire process. In the previous capstone project, I showed you a list of public APIs. So these are APIs that anyone can access as long as you have signed up or you have the correct credentials. Some of them are paid and some of them are free, but they're available to anyone on the internet. So this list encompasses pretty much every single topic, anywhere.
Damn, there's a lot. Where to see it? Course itu apa ya? Oh iya, course itu yang damn cool, bro. Keren, keren, keren.
From health to pets to public infrastructure. And I'm sure you had a good look through it in order to choose the one you wanted to use for your capstone project. The reason why we use APIs is because they make development so much faster. Instead of building out everything from scratch and collecting data, cleaning data, or building up services, you can leverage other people's existing data, their services, or their algorithms in order to build a product on top of that existing API. So you could go from 0 to 1 in the space of minutes rather than years. Now, a really good resource I recommend checking out is Rapid API. They're a company that collates and allows people to host APIs that customers or clients can consume from. Being able to do that, being able to cut down your development time and to leverage other people's work or data is a really valuable service. So that's why people often charge for it. And this website, Rapid API, is kind of like the Amazon for these paid APIs. They have free APIs as well, but it's mostly APIs that are developed by developers like you. And then they host it onto this website, and anyone who needs to use that website, for example, if you wanted to translate text or get hold of basketball data, then they can use these APIs and pay according to how many requests they make. Now, Rapid API also has free APIs that can be used for developers. So take a look and explore this website and see that if you were to create your own API hub, what it is that you could do on here. Now, what is it that makes an API monetizable? What makes it valuable enough for you to be able to list on Rapid API and for people to start paying you to use those APIs? I've kind of broadly thought about it in 3 categories. One is if you have a large and valuable data collection. 2 is if you have a proprietary algorithm or a really useful service that people can tap into using your API. And 3, if you simply just have a more simplified interface, a simplified API for people to be able to work with something else, be it a real world service or another API. What are some examples of that? Let's say you had a large collection. You had over 1,000 recipes for pasta. And your granny gave this to you. It's an heirloom and you've just kept it in a file all of this time. And today you decide to type it all up and make it available via an API.
Harus ada subtitlenya. Tai.
is it that makes an API monetizable? What makes it valuable enough for you to be able to list on Rapid API and for people to start paying you to use what it is that you could do on here? Now, what is it that makes an API monetizable? What makes it valuable enough for you to be able to what is it that makes an API monetizable? What makes it valuable? All right, it's time for the final project of the valuable enough for you to be able to list on Rapid API and for people to start master instead of building get there and you're going to be able to achieve those goals that you set. Instead of building out everything from scratch and collecting data, cleaning data, or building up services, you can leverage other people's existing data, their services, or their algorithms in order to build a product on top of that existing API. So you could go from 0 to 1 in the space of minutes rather than years. Now, a really good resource I recommend checking out is Rapid API. They're a company that collates and allows people to host APIs that customers or in the space of minutes rather than years. Now, a really good resource I recommend checking out is Rapid API. They're a company that collates and allows people to host APIs that. Now, as we're complying with RESTful best practices, we're going to be building on that customers or clients can.
Mulai juga tuh di HP nggak ada ininya, titlenya.
Well, that's probably valuable to somebody out there if they're building a recipe app or consume from. Being able to do that, being able to cut down their services while all of this time, and today you decide to type it all up and make it available via an API. Well, that's probably valuable to somebody out there if they're building a recipe app or if they're building some sort of application that needs that data. Now, on a more complex level, maybe you have a weather station and you can give people access to live weather data in any location. Well, that is also pretty useful, and that's probably a lot more valuable than pasta recipes. But it again falls into the data collection category. Now, the next one is an algorithm or a service. So, for example, let's say that you worked out anywhere on the globe if you were able to create a algorithm that looks at any two coordinates on the map, and you would be able to work out the direct line distance between those 2 points. Or maybe you could work out the distance that it takes a car to get there via the available roads. And you have some sort of very, very clever algorithm that uses other APIs or other things to work that out. Maybe the Google Maps API, maybe you have some sort of satellite API that you amalgamate into one algorithm or one service. And that is probably reasonably easy to build, and it's something that would save people a lot of time.
so that they don't have to build this themselves, and hence it would make your API valuable. Now, on a more larger scale and more complex version of this would be something like ChatGPT. It took them years and years to be able to collect all of the data from the internet, feed it into this large model, train it over years and years, which costs a ton of computer power and a ton of money. And by allowing you access to this service, then it makes sense that the developers who use this API would have to pay for it because there's a lot of value there. The final one is if we had a simplified interface as an API that you create. So let's say you wanted to be able to have an API that allows you to order a pizza. So you just give the API as input parameters your location and your card details, and then bam, you would have pizza arrive at your doorstep. Well, that's a pretty valuable API, and that essentially is taking a real world service that doesn't have any sort of internet enabled capabilities, the ability to order pizza from Domino's. Maybe they don't have an API, maybe they just have a simple web form, and you use something like Python and you cobble a whole bunch of things together in order to enable this call for pizza API. So that would be pretty useful. And on a more complex scale, you could maybe take some of the more large scale APIs like the Google Maps API or the Google Sheets API. And they're all kind of complicated because they allow you to do many, many things with that API, with Google Sheets or with Google Maps. But maybe you realize that in common situations, people only want to do one, two, or three things with it, and you simplify it down for them so that any developer can access that API and simply log some data in a Google Sheet with just a few lines of code instead of a few hundreds of lines of code. And that again, you're saving people time, you are making things easier for people, making things more accessible, and hence it also makes sense that it would be a monetized API.
Real world exact lines of code. And that again, you're saving people time, you are making things easier for people, making things more accessible, and hence it also makes sense that it would be a monetized API. These are actually real world examples. There actually is a developer who created an API called Domino's Pizza API, and it is a Node.js API. So that means you'll be able to look through the code and you should be able to understand some of the code to see how they actually created this API, because it's open source on GitHub. And all you have to do is search for Domino's Pizza API plus the word GitHub, and you'll be able to find this code base and see this API being built in real life. Now, this is an open API, so it's free to use and open to the public, but equally likely, this could have been an API that's hosted on Rapid API, in which case we wouldn't be able to see the source code so that other people don't just simply clone your code and take what you've developed. Another category of APIs are internal APIs. We've talked a lot about Another category of APIs are internal APIs. We've talked a lot about external, or rather public APIs. So these are available for anybody should they wish to pay or should they wish to sign up to use this API. But there is also another category of internal APIs. Let's say you work at a company, right? And you need to keep track of all of your inventory. You have a whole bunch of things. Let's say you are Amazon and you have all of these items in your warehouse and you need to be able to keep track of them. Or if you're a company selling encyclopedias door to door, then you would need to know, well, how many of these encyclopedias have been sold and how many do we have left to sell? This is pretty important in order for you to make sure that you never run out of encyclopedias. You might want to know, well, which addresses have been visited by your agents so you don't double up on sending agents to the same place. You might want to submit which addresses actually bought an encyclopedia in order to be able to analyze your data. And we've been building internal APIs, basically, every single time we've built a backend, because we haven't opened that up for anyone else to use. Now, as you realized, that doesn't mean that other people can't. It just means it's not documented and we haven't promised to support it. In many cases, a private or internal API is something that is not supported for external use, but unless you have security features in place, it doesn't mean that it can't be accessed. And in fact, this is a huge category where people try to figure out what are the methods in various companies' private APIs, which we won't go into right now, but this is something to be aware of. Not only when you're building your own APIs, but also when you are trying to figure something out on the internet. What we're going to be building in this module is a REST API. Unfortunately, it's not time to rest, but it is a time to build what's called a representational state transfer API. Don't sleep just yet. It's time to review what we need to do to follow the REST architecture. So it's essentially just a bunch of rules that describe how an API should be. Let's take a look. The first rule, and this is one of those classic interview questions, good to keep some notes on if you're thinking about applying for jobs. The question would be something like, what makes an API RESTful? And the number one rule for making an API RESTful is that it uses standard HTTP methods. You're already pretty familiar with this. It's your get, post, put, patch, and delete. And these are the standard verbs that you use to interact with our RESTful API. So that means if you wanted to grab hold of something from the API, you would use the get method. If you want to delete something, you would use the delete method. So far, pretty easy. The next rule is that it should probably have a standard data format that it responds with. That means something like the JSON format, the JavaScript object notation, or something like XML. And this is a response to calling the API, and the response is given back to the client. And RESTful APIs respond with something that is pretty standard, like JSON. This is the representation part of the representational state transfer. Resources are represented in a specific format, like JSON, and that is sent in response to the client. Again, so far, nothing too crazy. The next rule is that clients and servers in RESTful APIs are completely separate. They are not on the same system or in the same file. And they're able to message each other over a network in order to make requests and also to get back responses. And this part of the RESTful API architecture allows each side to be able to scale independently from each other, and they can evolve and be completely built separately by different people, which means the RESTful API allows the whole system to scale very easily. The next rule is statelessness. What this means is that each request from the client to the server should contain all the information that's needed to understand and process the request. So the server shouldn't be storing any sort of client-side state or client-side data between the requests. So what this means is that each single request can be complete and each single response is also complete without need to know what happened previously. And this basically, again, allows better scalability of the API, and it simplifies the server-side implementation. So every single time the client makes a request to the server, it contains all of the information that the server needs in order to figure out what to respond back. And the server doesn't need to check, oh, what did this person ask for previously? Or, last time I sent them the fourth item. So if they're requesting now, they must want the fifth item. That means that you need to keep track of state. And it means that if you have multiple clients coming in, it can quickly reduce your efficiency and scalability of your API. This rule basically allows the server to serve many, many clients and many, many requests. Next is that your REST API is resource-based. So it is an API that is centered around resources and uses a unique resource identifier, also known as a resource locator. So this is a URI or a URL in order to locate specific resources. We all know what a URL is because you use it every single time you try to access a website, but know that a universal resource locator is simply just an address for a particular resource. And it's a type of a universal resource identifier. It identifies that resource in the API. You might have seen all these 5 rules and thought to yourself, this seems kind of familiar. A lot of this just seems like it's the internet. Well, if that is true, then you are very much on track because the internet, as you know it, the World Wide Web, is considered one of the most successful implementations of RESTful architecture because we have our resources located in URLs. So this is how we can identify what it is we want to access. We work and interact with the server through an API using HTTP standard protocol. And the responses we get back are standard data formats such as JSON or XML or JavaScript or HTML. And also we have a strict client-server separation. So the client is the person who's using the browser and the server is the computer that holds all of the data that is needed to be served when somebody requests a particular web page. And finally, the internet is pretty much stateless. Every single request to a web page contains all of the information that's required in order to determine what web page to send back. This is also why we're learning to create RESTful APIs, because it is a key concept in web development. And because we're learning to become web developers, then it's pretty important that we get our heads around how to build RESTful APIs. The API that we're going to be building is a joke API. It's a RESTful API abiding by all of the rules that we talked about, and it serves up jokes to anyone who wants to access that API. Maybe you're a pretty good joke writer and you've written, let's say, 100 good jokes and you've categorized them into different types, different categories, and you allow anybody to be able to tap into your API and get hold of some jokes. This is going to allow us to see how everything works in practice by building this API from scratch. Once you're ready, let's get started. We're going to be building our API using the HTTP verbs, and we're going to start using the get method. So how can you get hold of jokes using our API? We're going to be building this step by step with a hands-on approach. The first thing I want you to do is to go into the course resources for this current lesson and download the Postman collection.json file. Once you've done that, I want you to go ahead and open up Postman, which you should already have installed, as we went into this in detail in our API section. Then I want you to go into Workspaces, My Workspace, and here, if you go into the Collections section, I want you to go ahead and click on Import. You're going to drag and drop that file that you just downloaded right into here, and once you've done that, it'll open up and give you access to this joke API Postman collection that I've created for you. You can see in here we've got all of our familiar verbs: the get random joke, get specific joke, get a filter joke by joke type. We can post a new joke, put a joke, patch a joke, delete a joke, and finally delete all jokes. So these are all of the endpoints that we're going to be building in this module. And we're going to start off with the simplest one, which is to be able to get hold of a random joke. In order to see what our API should look like, you can take a look at the docs, which gets automatically generated when you create a new Postman collection, such as the joke API collection that you just opened up. You can either scan this QR code using your phone or type in this long URL into your browser, but either way, it will take you to the Joke API documentation. And this gets completely automatically created. All I had to do is to add in some text here and there and give it some requests, run the requests, and save those requests in Postman. For example, if you were to create a new collection and you create a new HTTP request, a GET request, you enter some sort of URL, and then you go ahead and hit send, you'll be able to save this request to a collection, and you'll be able to generate the documentation automatically in the same way that I have done. So let's go ahead and delete this and go back to our joke API. Here, you can also go to the documentation by clicking these three dots, viewing the documentation. And in my case, I've actually published it onto the web, which is why you can visit this URL and see what all of the requests should be and navigate to the one you want. The first job of ours is to be able to hit up /random as an endpoint here. And the request looks like something like this in the terminal, which is using curl or curl. And in our case, if it was using Axios, then it also gives you some example code as well, which is kind of neat. But let's leave it on the simplest form, which is what you'll see most APIs documented in, which is curl. And if you take a look at the example response, you'll see what kind of data we would expect back. So it's a JSON format with an ID, with a joke text, and a joke type. So this is our entire joke object that comes back as a JSON. The first challenge is to get hold of a random joke. So hit up this URL endpoint, localhost 3000 /random, and get back a random joke from the collection when you hit send. Take a look in the course resources for this lesson and download the starting files in the 6.0 DIY API zip file, extract the zip file on your system, and open it inside VS Code. Once you're here, you'll see that you've got the index.js file, which is where you're going to be writing all of your code. And you can see we've got all 8 of the challenges listed out for you. And we're starting out with this one, number 1. You can also run the solution.js file. And you can do that by simply CDing to this repository, making sure that you've installed all of the node modules required by running npm i. So this is going to look inside the package.json and grab all of those dependencies that we've listed, EJS and Express. And once you've done that, you can use nodemon to run solution.js. And once it's up and running at port 3000, you should be able to go through each of these requests in the joke API, and you should be able to send a request and you will see that it works. Now, I've set up everything, including the path variables for the specific jokes, the query parameters for the filtered jokes, but we're going to go through them one by one, so don't worry too much about that right now. The first one we want to make functioning is to be able to get hold of a random joke. And you can see each time the joke changes, and it's looping through the list of jokes that I've included in the starting file for you. So if you scroll down to the bottom, you can see there is this variable called jokes. There's all 100 of them in here that I've created for you. And all you have to do is to use what you know about JavaScript, Node, Express in order to create your API route here that will return with a response that is a random joke. You can either do this as a challenge, which is a little bit difficult because we haven't really gone through it yet, or you can continue and watch the slide deck with me to see how this is done. This endpoint will look something like this. We know it is this. This endpoint will look something like this. We know it is a GET request, so we're going to need to use the app. Get, which comes from express. This is where this method comes from. And then the first parameter we add into this method is the route. So it's the endpoint, basically, where we want people to be able to access this. And you'll see this in the documentation, also in the Postman API collection, but the route that we want to create is /random. And then the next part comes the callback. So what should happen when this request comes through? In our case, what we want to do is we want to tap into the request and the response object. We want to get hold of a random number by using math.random and multiply that number, which will be 0. something, so 0.1, 2, 3, 4, 5. And then we multiply it by the length of the joke array, which is 100. And that will give us a random number between 0 and 100. And then finally, we use math.floor in order to round it down. And we can now use this random number to grab hold of a random joke from the jokes array. And then we can send it back out as a response by using res.json. Res is the response, and .json is simply a way of converting our data here, which is in the format of a JavaScript object, into a JSON object, and then returning that back out as the output. So this is all that it takes in order to complete this part of our API. So I want you to take a look at this code. Think about if you understand what each part of it does. If not, take a quick Google, use something like W3 Schools or Google Stack Overflow, investigate each part of the code that you don't understand, fully understand it, and then go ahead without looking, see if you can figure out how to implement it on your own in VS Code, right here under challenge number 1, get a random joke. Pause the video and complete that part of the challenge. So now challenge 2 is still another GET request. And in this GET request, what we want to do is to hit up the /jokes/:ID. You might remember this, but this :something something is a way for us to be able to tap into a URL or a path parameter. So we can specify that in Postman by going to the params tab and then scrolling down to the path variables and then adding a key and a value. This is equivalent to hitting up http localhost 3000 /jokes/2. That's basically how Postman is going to reformat this request. And once that gets received in our API server, then we should look for a joke that has the matching ID and then send back the joke object that corresponds to that ID. That is your challenge number 2. Now, again, you have 2 choices. Depending on what you want to do, you can either use what you've learned in the last challenge to try this out on your own, or you can follow along with me and continue watching while we go through how to do this. Similarly to previous we need our app.get in order to address when we get a GET request to our server and that GET request matches this endpoint /jokes/ a particular ID, what we should do. When we get hold of that ID, when it comes in through the request.params.id, this is how we access any of the URL or path parameters in Express. So remember, there is request.query and there's request.params. Params is in the endpoint URL, so /something or other, and query comes after the question mark. So it could be query ID equals 2, but in this case, we chose a path parameter, so we're not using the query. What this comes in as is going to be a string. However, in our jokes object, the ID parameter is in the format of an integer. That means when we're doing this checking mechanism, if this is not an integer, then this check is going to come back as false. There are 2 options here, and depending on which one you prefer, you can pick and choose. The first option is to use the JavaScript triple equals, and this operator says the left-hand side must strictly equal the right-hand side, including their types must match. If the right-hand side is a number data type and the left-hand side is a string data type, even though they are both 2, this check, this triple equals, does not pass. Alternatively, you can use the JavaScript double equals operator. And this is a loose comparison. In this case, the type doesn't matter, and JavaScript will perform a type conversion if necessary. You can choose either of these 2. For clarity's sake, and in my mind, just for me to actually know exactly what I'm working with, I like using the triple equals because it means I'm not assuming anything. I know exactly what's going on. But for that to work, we're going to have to convert this string into a number, or in this case, into an integer. And we do that using the native built-in method parseInt. That will convert the string into an integer and store it inside ID. And so we can check ID against joke.id, and they are now the same type and hopefully the same number if we want to get hold of it. Now, the other thing you'll notice here is that in order to find the joke, I'm using the JavaScript find method. This takes an array, and then you use the .find method. And then in the brackets of this method, it expects a callback, which should return true on a particular condition. This callback takes a object, joke. Essentially, behind the scenes, it's going to loop through this array, go through each of the items, and you can call each of the items whatever you want, joke or a or whatever variable name you want to give it. And then it's going to check against a particular return condition. Is the ID of that item we're currently looping through equal to the ID that we are checking against? And you've seen this in our JavaScript module, so hopefully this shouldn't be too crazy. And if you wanted to review some of these methods such as for each or find, or that's a good point actually, there's multiple ways of doing this. This is just one way that I find pretty efficient and pretty quick to do, and also doesn't involve a lot of lines of code. But equally, you could use the standard for loop in JavaScript, you could use the for each, you could use anything that works, essentially. It doesn't matter at the end of the day, as long as you fully understand what's going on. And once we grab hold of the joke that matches this criteria, that's a joke with the matching ID, and then we send it back as the response in a JSON format. Now, check to make sure that you understood everything in this code, and then go ahead and implement it. The process that we're replicating here is less like a coding exercise. I'm not really expecting you to be able to come across each of these challenges, say, write the API server code to be able to get hold of a specific joke just by looking at the criteria that's listed in Postman. Instead, it's kind of more akin to what happens when you're developing in real life and you look for a solution to a problem you have. You come across a solution on Stack Overflow. But now the important part is you got to figure out, well, what does all of this mean, right? What does it actually mean? And before you move on, you understand all of the code, and then you can replicate the code in your own solution. Go ahead and do that under number 2 to get a specific joke by ID. So pause the video, and then once to get, go ahead and do that under number 2. 2 to get a continue. All right, so the final get request number 2 under understand all of the code, and then you can replicate the code in your own solution. Go ahead and do that under number 2 to get a specific joke by ID. So pause the video, and then once you've done that, we'll continue on to challenge 3. All right, so the final get request challenge is to filter the jokes by a particular type. And in this case, we are specifying the type by using a query parameter. In the params tab, if you go to query parameters, you can add a query with a key and value here, and it will automatically format your query into the URL. So this is something that Postman does really well. You can add as many queries as you like, and you can test them by hitting send on your solution.js. And what it should do is it should pull back an array of jokes that all match a particular joke type. So if you look inside the joke variable in your code down here, you'll see that they have different joke types. Some are science-based, some are pun, some are wordplay, etc., etc. And what you want to be able to do is to send a request to your joke API and specify a joke type in the query parameter, and it pulls back all of the jokes that match that particular joke type that you requested. That's the goal. And again, I'm giving you the option of the extra hard challenge where you figure out how to do this all by yourself as a big challenge, or we run through everything together and then you implement it. Pause the video now if you want to do this all by yourself. Or you can give it a go and then come back and see us work through it together as well. The solution in this case is going to hit up the /filter endpoint, and the type that the client is requesting lives in the query parameter. And we get hold of that by tapping into request.query and then whatever it is the parameter they've typed in. This is where our documentation comes in handy, because if we look at get filter joke by type, you can see that there should be a parameter called type. And this we are telling the world because we're building a public API, right? We're saying this is how you can filter a joke. And you have to make sure that the query parameter is spelled this way in order to get it to work. That is how we've set up our query parameter. This is the name of the query. And then I'm using the filter method on arrays in JavaScript in order to pass in we try to filter an array that we've specified. Filter method in documentation, and make sure you understand before getting will ever developers what the code actually anyone can what the code does. Get requests.js and make sure that those parts in the joke API collection, all of the get requests still run and respond. As you would expect with 200 and also getting back the items that you expected to get back. In the next lesson, we're going to look at making a post request in order to add new data to our API. So for all of that and more, I'll see you there. All right, so now that we've covered all of the GET requests, it's time to cover some of the posting and updating methods. So our post, put, and patch methods to create new jokes to add to the API and update the jokes that are in the library. The first one we're going to tackle is the post request. We want to be able to hit up the /jokes endpoint and to submit content in the body of the request using the www form URL encoded format. And the two parameters that we can hit up is text and type to provide the text of the joke and the type of the joke. And these are two strings that we will use to submit our new joke. The ID should be automatically created by adding an ID that is one higher than the last ID in the jokes array. And the other two pieces of data that comes from the body of the request will then get added to a JavaScript object and included in the jokes array that's in that variable called jokes. So if you want to try this yourself, pause the video now, but otherwise, let's walk through how to do this. We're going to use a different verb now, and this method comes from Express. It's the post request that you've seen before. before. So using app.post, we specify the endpoint that we want to receive this request on /jokes, and then we provide our callback to handle that request. The first thing I'm going to do is to create a new object, which I'll call new joke. And in the new object, I've got my ID, I've got my joke text, and I've got my joke type. These three parts that create the joke itself. The ID I'm simply going to create by looking at the length of the jokes array. You'll notice that they are numbered from 1 to 100, and the length at the moment without any modification is 100. So 101 will be the next one, and then once we're on 101, the next one will be 102, and so on and so forth. So this will be automatically created without needing to get hold of this data from the user. Now, the next two parts use request.body.text and request.body.type. If you scroll through the index.js, you'll see that I've already included the body parser code that is required for us to be able to tap into request.body. And I've added URL encoded as an option to true, and we're basically ready to go using that middleware in order to receive these two pieces of data. As I specified before, you can also use Express as a native parsing ability, but for me, I prefer using body parser because it just makes it clear to me, perfectly clear, what that part of the middleware does. And you'll see developers using body parser on NPM all day long, all the time as well. So this is very much standard practice. Once we've created this new object, we're going to push it to our array of jokes, add it right to the end of that array, and then we can also console log the last joke, so jokes slice -1. This line of code basically is equivalent to saying take all the jokes and then access the one at index, which is the last index. And this is how we would do that in JavaScript using the slice method. So slice the jokes and then access the one at index, which is the last index. And basically is equivalent to saying take all the jokes and then access the one at index, which is the last index. And this is how we would do that in JavaScript using the slice method. So slice from 0 backwards, which somehow in JavaScript land goes back to the very last item and picks it out. You can try this for yourself and see it. Don't just take my word for it. And then finally, we're going to send back the new joke that the user created. Take a look through this code, make sure that you understand everything. If you need to look anything up, such as the slice method, you can check that out. And you'll notice that the object I'm sending back as the JSON to the client is the one that they created. This comes from all of their data, rather than the one that comes from the last item in the array. You can make the design choice of sending this back to them, just in case you wanted to check that this works. And you can also add in error handling or add in some checks, making sure that the joke text contains however many characters you want it, and the type of joke matches a certain list of types that you specified. We can always extend this API. But the key point here is you know how to write the API to handle a post request. That's all that I'm looking for here. Pause the video, implement this in your own index.js if you haven't done so already. So just walk through how to do this. We're going to use a different verb now and before, so it created without needing to get hold of this text and see it as this works. The type of joke and this implement. As a reminder, a put request is a complete update. That means you have to put. That's all that I'm looking for here. Pause the video. Reminder, a put request. Challenge number 5, we're going to make a put request. So just as a reminder, a put request is a complete update. That means you have to provide all of the parts that are not automated into the object. So in our joke, that is providing the text, providing the type, and of course we'll need the ID in order to get hold of that particular item. Now the ID identifies that object in the array, so we don't want to update that unless we want to mess everything up. That's the one thing we're going to keep constant, but the rest and all of the content of the joke object is going to be completely replaced. In Postman, you should be able to send a put request if you have the solution main.js up, that server running using NodeMon, you should be able to send this request and be able to update completely the joke with a specific ID. So if you take a look inside the params tab, you'll see that I've specified an ID of 2, and that's the joke I want to update, which gets replaced in this endpoint URL, becomes /2. And then I'm providing some text and the type. And you'll notice that if you leave one of the or put to be able to see it, or either pause the video now, me, and the thing we're going to do is we're going to get hold of the ID that comes in from request.parameters.id. And again, remember, you can either choose to pass this int to turn it from a string to an integer so that you can use the triple equal sign operator, or you can choose to not pass it and simply use the double equal sign operator to check for vaguely equals. And this is exactly equals. That's kind of how I think about it in my head. Now, the next thing is we're going to grab hold of the ID, the body text, and the body type. These two come from the form submission. And then we're going to find that particular joke. Because we need to replace that item in the joke array completely, I'm choosing to use the find index method. This is going to allow me to add a callback into that method for a match criteria. So it's going to loop through each of the jokes inside the jokes array. It's going to check each of their IDs against the ID that we put in find index if this is the first time you're coming across this method. And The final challenge in our post put and patch is the patch request. The patch request is like our little patchwork quilt. It is a little update to a complete resource, and we're only choosing to update one small bit of it. And as you might have already realized, this is most often what you're going to be choosing when you're making an update to a resource. You don't want to update the entire thing. Say if you have a user, they have their address, their name, their password. There's very, very few instances where you would want to provide all ID going to be of the number that we've got or can do this. I've, as always, opted for the most readable version. So we're going to use the app.patch method from Express, provide the endpoint that we want to hit up, provide the callback to handle that request, pass the integer from the request.params.id so that that number 2 string becomes number 2 as a number. And then we check it against the joke ID by looping through all of the jokes in our jokes array, checking each of one of them and finding the joke that matches. So we store it inside existing joke. And then we construct our replacement joke. And notice here what I'm doing. The two things that we can patch in this joke is the text and the type. What this code does is it checks to see if there is a request.body.text, if the patch request actually included some text in the body of the request, in which case replace that in the joke text. But if this is nil or it doesn't exist, then this or operator is going to allow the second part, which is the existing joke that we found, and grab the text from there anyways to put it back into this new object. Essentially, this or statement says, go for this if it exists, otherwise go and set it to this. And this is a really neat pattern that you'll see very often. You can, of course, make this more complicated or then this or operator is going to allow the second part, which is the existing joke that we found, and grab the text from there anyways to put it back into this new object. Request actually included some text in the body of the request, in which case replace that in the joke text. But if this is nil or it doesn't exist, then this or operator is going to allow the second part, which is the existing joke that we found, and grab the text from there anyways to put it back into this new object. Essentially, this or statement says, go for this if it exists, otherwise go and set it to this. And this is a really neat pattern that you'll see very often. You can, of course, make this more complicated or more readable in your case by using an if statement. You can say if request.body.text exists. So just simply by leaving it as if this has any value, it's going to evaluate to true, in which case we can go inside this curly braces and we can set the joke text to this request.body.text. And we can write it in many, many, many lines, but this is something that you might see out in the wild, and this is one very efficient way of doing it. If you've never seen this before, test it out in your console or in a blank piece of JavaScript file, just to make sure you understand what's happening here. and grab essentials that you're located as starting at the tag just to make sure the user requested them that everything's doing, such as the find method, the find index method, and check that done all of that. Make sure you use nodemon to and then implement it yourself. Once you've done all of that, make sure you use nodemon to run your index.js and check that all of the routes in the collection, post, put, and patch all work as you expect it to. So take a look in the param section, take a look inside the body section, make sure that all of these parts you should not have to change, but when you send it, it should come back with a correct response instead of an error. So obviously in my case, index.js, none of these things have been implemented, so that's why I'm getting that error. But in your case, if you've written the correct code, it should work as expected. Now, all we have left is figuring out how to delete jokes. So that's what we're going to be doing in the next lesson. All right, so now that all we have left is the delete method, but I'm splitting it into two parts so that we can try out adding some basic authentication as well. We're going to be implementing the API for people to be able to delete jokes from the jokes API. The first challenge is challenge number 7, and we're going to hit up /jokes/ the ID parameter. And then this is going to hopefully delete the joke with that particular ID. So we're only deleting one joke in this case, and we're passing the path variable of ID and giving it one that hopefully matches one of the jokes in the API. We hit send, and this delete request will come back as OK with code 200 if everything went OK. Again, I give you the choice of trying to figure out how you can do this yourself, which can be a little bit tricky, or let's go through everything together. Can be a little bit tricky. I give you the choice of trying to figure out how you can do this yourself, which can be a little bit tricky, or let's go through 100 if everything went, and this delete request will come back as OK with code 200 if everything went OK. Again, I give you the choice of trying to figure out how you can do this yourself, which can be a little bit tricky, or with code 200 if everything went OK. Again, I give you the choice of trying to figure out how you can do this yourself, which can be a little bit tricky, or with code 200 if everything went OK. Again, I give you the choice of trying to figure out how you can do this yourself, which can be a little bit tricky, or let's go through everything together. We're using the delete method from Express, and we add in our endpoint, and in the callback we get hold of the ID that was added to the request. So again, we can either use pass int, or we can replace this triple quote into double quote. Either of these options will work. I'm using find index again to find the index of the joke that matches the ID that was passed in, this one. And then if the index is greater than -1, so if it actually exists, then I'm going to go into the jokes array and use the splice method in order to remove the joke with that index. That's essentially what this line does. It takes the search index and then removes only one element from the array. And once that's all done, I send status 200, everything is a-okay. But if there were any errors, then I send status 404 and tell them what the error was. That's all that's required to delete a single joke, and because it's just a single joke, we don't have any authentication in here. The next challenge number, we don't have any Authentication in here is a verifier. The next challenge, challenge number 8, simulates a situation where you need an API key in order to be able to delete something. Because in this case, we're actually saying, let's delete everything in our joke API. Let's just wipe our database, which, as you can imagine, is a very dangerous thing to allow people to do. In this case, we're saying you need to have a master key, which is in the format of a multi-letter code. And that is going to be added as a query parameter under the key of key. And when you have access to that, then you can make a delete request to /all. And when you hit send, it will delete everything in the database. Nuclear option, basically. So the actual deleting part is very simple. We're just wiping the whole array clean. But how we do authentication is something that is a little bit new in this case. Again, you can take a look at the starting code. If you scroll right to the top, you'll see a variable called master key. And that variable is going to be something that we're going to learn in later modules when we learn about authentication, we learn about how to generate unique UUIDs. But let's just assume that we somehow have access to a master password, which is called master key. And the user needs to enter it when they make this API request. We check the value of master key against the value that was inputted by the user. And if they happen to match, then we say, okay, we'll just go ahead and delete everything in that jokes array. So again, either you could have a think about it, try it out yourself, see it as a challenge, or we can walk through it together step by step. All right, so at the top of the
Oh ya.
file, we've got our master key, and this is the copy that we're keeping on our server to check against what the user sends in. Now, the user is going to use a query parameter in the URL, so it'll be /all, and then it will be query parameter, which is called key, and they make it equal to whatever it is they decide to type in. And we have to check if the user key is equal to the master key, and in this case, all we're doing is just wiping the jokes array clean, setting it back to an empty array. And in this case, we send status 200, everything was implemented as you requested. Otherwise, we say 404 and we say you're not authorized to perform this action because the else statement is on this check right here, if the user key is equal to the master key. So this is a very simplified way that we can implement API key authentication or username password authentication. And as I mentioned before, later on when we properly look into authentication, we'll look into generating these unique IDs, we'll look into hashing passwords, storing passwords, we'll look into bcrypt, we'll look into how to hack passwords and all of that. But for now, we can be satisfied that we're just doing a very, very basic password check. So the admin password against what's typed in the request. And that gates our API and makes sure that anything that is risky is not performed by just any user on our service. That's it. Check to make sure that your code matches what's in the solution, or if it doesn't, make sure that your functionality behaves as you would expect to. And once you're ready, head over to the next lesson. We're going to put all of these skills that we've learned in this module to practice by building a blog API. So for all of that and more, I'll see you there. All right, it's time for the final project of the month.
Kasih istirahat makan. Aku mau beli makan dulu coy. Info file bang. Wah. Ah, aku mau beli makan dulu. Pergi pergi beli makan. Yo, I'm back.
Module, and we're going to be building. All right, it's time for the final project of the module, and we're going to be building a blog API. Notice how we're building the API for the blog in this case, and we're not actually building the front end. What I mean by the blog API? Well, we're going to cover all of the HTTP requests apart from put. These two are both update methods, and we can choose which one we want to do. But in this case, what we want to do is only to have get, post, patch, and delete. And what this is going to enable us to do is to allow our front end, which I've already built a very simple example for you, to connect to our back end, our server, and it's going to be able to display all of the blog posts in order. It's going to display their titles, their date of creation, their author, and their content, which for now is pretty short. In addition, we will have all of the CRUD methods, such as create, so we'll be able to create a new post, and you'll see that show up at the bottom. We'll be able to update posts, so it will display the existing title, content, and author. Or if we take a look at one of the larger blog posts, you can see that more clearly. And we should be able to change this by making a patch request. So we're only changing one part or a couple of parts of the entire post, and we're only providing the updates. So that is our patch request, and you can see I've now secretly taken over this blog post. It's now by me. And finally, we can also delete. So let me just delete this test post. You can see it's now gone. If you go ahead and download the starting project, the blog project from this current lesson, extract it, and open it up inside VS Code, you'll see that there are the usual things that you're familiar with. So you'll need to run npm-i in this current folder directory in order to install all your node modules before you get started. And then if you take a look inside the index.js, which is where you're going to be writing your code, completing these 5 challenges in order to make the get, post, patch, and delete requests to work. And you'll see that what's happening is that we'll have 2 servers running simultaneously, one from server.js, which is going to act as the backend that makes the API requests. So if you imagine somebody using your API and building a backend, and the other one, which is the index.js, which is going to be our backend for our actual API. So this is the one that actually responds to the API requests from external servers. So this is quite important. We can't run 2 pieces of code, which is going to be our backend for our actual API. So this is the backend that makes the API requests. So if you imagine somebody using your requests to work. And you'll see that what's happening is that we'll have two servers running simultaneously, one from server.js, which is going to act as the backend that makes the API request. So if you imagine somebody using your API and building a backend, and the other one, which is the index.js, which is going to be our backend for our actual API. So this is the one that actually responds to the API requests from external servers. So this is quite important. We can't run two pieces of code on the same port. That doesn't really work. In order to get up and running and to test it out, what I recommend is to go ahead and firstly cd into the project folder, and then make sure that you run npm i to install everything in there, and then use nodemon to run the server.js. And once you got that up and running, you should be able to visit localhost 3000, and it will tell you error fetching posts. That is because there is currently nothing running on the port where the server.js is looking for the API. So port 4000, localhost 4000. And this is what we're going to try and do with our index.js. So you can go ahead and create a new terminal and again, do all the required preamble. So cd over and then nodemon index.js. Unfortunately, even though our API is now running on localhost 4000, this is still not going to work because we don't have any of the routes defined just yet. What you can do instead is you can do a Control-C to stop this, and use nodemon to run solution.js, which is also going to go onto port 4000. And now if you refresh your localhost 3000, the server for the website is now actually reaching to the API. So the server port 4000, use nodemon to do a Control-C to stop this, and use nodemon to run solution.js, which is also going to go onto port 4000. And now if you refresh your localhost 3000, the server for the website is now actually reaching to the API. So localhost 3000 is hitting up localhost 4000. And it's now all working because all of the routes have been defined in that solution.js. So you can compare and contrast. But while you're working on your own code, when you need to test it, you'll need to stop this because you can't run two pieces of code on the same port. And this is what will happen if you try to do that. So let me try and run nodemon index.js alongside solution.js. We get this error. You can see app has crashed. And if you scroll up, you can see the code is EADDR in use. And this is because you'll see the error that says address already in use. So you should realize that this is because we have this solution.js running on localhost 4000. So if we want to run our index.js, then we have to first stop this one by using Control-C. And then we can try to stop this one and then try it again. So now that that port is now freed up, then we can use it. So essentially at any time point, you should really only have two terminals open. One should be running localhost 3000, which is going to be running the website that is hitting up our API. And the other one, localhost 4000, which is the server where the API requests are handled. And if you want to test your index.js, that's what's going to run on localhost 4000. If you want to see what the solution would do in order to serve up the API to the front end, then you run the nodemon solution.js. The goal is for you to be able to complete this independently based off what you've seen in this module. So we have two gets, a post, a patch, and a delete, and it should be relatively straightforward, but you might need to review some of the lessons in the previous parts of this module. I'm going to let you pause the video, and I'm going to let you get on with it. You'll know once everything works because you'll be able to run nodemon index.js, and it will allow you to create a new post. It will add the post to the bottom of our blog list. It'll allow you to edit new posts. You can update them as you wish, and you'll see them update in here. You can delete posts as you click on the delete button, and that's all the functionality there is in this blog post. So pause the video and see if you can figure out all of the challenges for this project. All right, hopefully this was relatively straightforward given that you have completed the previous parts of this module, and we've gone through most of these routes in creating an API: get, post, patch, and delete. If we take a look through the solution code, you'll see that it is relatively straightforward. To get all posts, all we're doing is returning the posts as a JSON using res.json. And posts is this array that we've already created here as a in-memory data store where we've got the ID, the title, the content, the author, and the date. And in later modules, when we cover databases, we'll take this out of the current memory and we'll store it on a database. But for now, this is great for learning how to build our API without getting bogged down in all the rest of the database stuff. We've got our get, which is get all posts, which is relatively easy. We've got the get a specific post by ID. So we have an ID path parameter, and then we try to find it inside the post array. And then if we do find it, then we go ahead and return that post as a JSON. But if we don't, then we turn 404 and the message post not found. When the user posts a new post, we can see that the server.js will try to hit up our API at the API URL /posts. So that means that in our index.js, we have to also make sure that that route exists at that endpoint. And when it does, we try to get hold of all the things that are sent over, including the body.title, body.content, body.author. And remember, we're able to do this because we're using the middleware body parser, especially this part where we get hold of the URL encoded form data. And as always, you can explore the different parts of the form. So you can see that in the views folder, you'll see that in the modify.ejs, we've got two forms. One, which is an edit form for the patch request, and one is a new post form for the post request. And you can see what are the names of each of these fields. So content, author, title, and that is of course what we need to target when we are getting hold of body dot something. So this part has to match whatever is in that modify.ejs form. And then the date, we're simply using new date to use the JavaScript date module to create the current date and time. And we store all of that as a post object, which we push onto the array. And the ID, we simply synthesize by adding 1 to the last ID, which is this variable we're tracking here, and we increase it each time we create a new post. The patch request is similar in terms of the fact that we get hold of the data from the modify.ejs with the same name for each of the fields, and we try to grab that data in our route and we use it to update the post. So first we find the post with the ID that we are looking for. So that's passed in as a path parameter. And then if that post doesn't exist, then we simply straight up return a 404, post not found. But if it does exist, then we look to see, well, did we get a new title? Did we get a new content? Or did we get a new author? And if so, we go ahead and replace those relevant parts. And then we send back the updated post as a JSON. And then finally, as a part of the delete request, we get hold of the ID that is deleted. So if we take a look at the index.ejs, next to the delete button, it's an anchor tag that links to /API/post/delete/ the ID of the current post, because this is a for each loop using our EJS. And for each of the posts in that array, we assign the post ID already to that URL. So that's going to hit up the server.js, where if you take a look at the delete, it's going to go to this endpoint. And then it's going to send a request to our backend, our API, and under /posts/request params.id, which is what it gets sent in the path parameter right here from the server running on localhost 3000, the one making the API requests. Then we're able to make that delete request in our backend right here. And essentially, we're just finding the index, making sure the index actually exists, and then splicing the post to remove that particular post with that index. And now we're getting closer to getting the two servers to communicate to each other. The server.js, which is the website making the API requests, and the solution.js, which in your case is index.js, which is the backend of our API that we're building that's handling those API requests. You can imagine this as somebody who wants to use your blog API, writing this website and hitting up your API in order to handle all all of the complicated parts of creating and saving blog posts. And this gets reading and saving blog posts. And this gets really close to real life. And as you'll see later on, when we start merging our front end and back end, you'll see this all coming together. But this will take a little bit of time to wrap your head around. So don't worry if you didn't get it the first time. If you got stuck at any point, be sure to review the solution code, but also review all of the different parts of the code base. There's nothing in here that you haven't seen before. You've seen EJS files. You've seen how the back end of a website should work. You've seen how we can make these Axios requests. You've seen how we can create our own APIs. It just takes a little bit of time for everything to come together in your own mind, and that's okay. Don't beat yourself up about it. It takes us all time to read code. And in fact, I would say it takes longer to read code, a lot longer than to write code, because you're having to understand somebody else's logic. You're having to understand how a lot of different pieces play together. But just try practicing this a few more times. If you didn't get it the first time, try it again with the explanation and looking at different parts of the code base. So hopefully you were able to build out the blog API and you have a functioning blog up and running, and you might even create some cool APIs of your own. If you do, be sure to either hit me up on Twitter or head into the Q&A and post to all of the other students and show us what you've built. Maybe we'll be able to use it and we'll be able to build cool projects based on your work. So I hope you enjoyed this module. I'll see you on the next one. All right, it's time for the final project of the... Now, a lot of students are taking this course. Final project.
Hah? Everything sucks. Not really. Everything is great. Huh? Terus?
Sent over, including name for each of the field button. It's we can, which is we've already created this mod in here. You can delete. It's a post, a patch, and a delete, and it should be right that is hitting up our in use. You try to do that. So let me try localhost 4000, localhost 3000. Unfortunately, even with our index.js, the port and that you run npm i to install everything in there, and then use nodemon to run the server.js. And once you got that up and running, you should be able to visit localhost 3000 and it will tell you error fetching posts. That is because there is currently nothing running on the port where the server.js is looking for the API. So port 4000, localhost 4000. And this is what we're going to try and do with our index.js. So you can go ahead and create a new terminal and again, do all the required preamble. So cd over and then nodemon index.js. Unfortunately, even though our API is now running on localhost 4000, this is still not going to work because we don't have any of the routes defined just yet. What you can do instead is you can do a Control-C to stop this and use nodemon to run solution.js, which is also going to go onto port 4000. And now if you refresh your localhost 3000, the server for the website is now actually reaching to the API. So localhost 3000 is hitting up localhost 4000. And it's now all working because all of the routes have been defined in that solution.js. So you can compare and contrast. But while you're working on your own code, when you need to test it, you'll need to stop this because you can't run two pieces of code on the same port. And this is what will happen if you try to do that. So let me try and run nodemon index.js alongside solution.js. We get this error. You can see app has crashed, and if you scroll up, you can see the code is EADDR in use. And this is because you'll see the error that says address already in use. So you should realize that this is because we have this solution.js running on localhost 4000. So if we want to run our index.js, then we have to first stop this one by using Control-C. And then we can try to stop this one and then try it again. So now that that port is now freed up, then we can use it. So essentially,
Hey guys, welcome to a brand new module. In this module, we're going to be learning all about data persistence.
Hey, well done for making it through another module. I know the last one had a particularly hard challenge, so if you made it this far, then great job, well done. Now, I want to talk to you about Hey guys, so we're now finally ready to start learning about Postgres. This is going to be our database management system that we're going to use to be able to persist our data on all of our web apps. As I mentioned before, the reason why we're choosing to use Postgres is because it is widely used by many of the top companies that you would have heard of, like Apple or Twitch or Instagram, and even NASA uses Postgres to manage their data. As you can see, for our purposes, it's clearly going to be more than enough. Postgres themselves say that they are the world's most advanced open source relational database. For us, what that means is it's widely used in the industry, as we already saw, and it's also free and open source, so we don't have to pay a single cent to use this powerful technology. But in addition, there's also great career opportunities after you learn Postgres because it's used so widely in a lot of companies and also in a lot of industries. Finally, it has great community support because lots of people use this. As I showed you earlier, it's one of the top most used database management systems by professional developers. So that means if you do get stuck, there's plenty of help available because there's lots of people familiar with this technology. So how are we going to use Postgres? Well, we've got our client, as we've seen, our front end of the website that is going to hit up our server side, which is going to be the part that's going to handle the requests from the client. And in order to handle those requests, there is business logic in the app part of our website, the app.js or the index.js, that handles the requests, figure out what it needs to do. And that part is what's going to talk to our database. Our database here is responsible for storing things such as user details, user emails, passwords, or if you have a blog, maybe it would be storing the posts and other types of data. If you have a to-do list, it will be the to-do list items. If you have a social network, it'll be the likes, and so on and so forth. You get what I mean. All of the data that needs to be stored permanently to be retrieved by the app, depending on whichever conditions. For example, somebody wants to pull up a blog post from November 2021, then they're going to hit up the database, grab that piece of data, and the app knows how to send it back via the correct response codes and to format it for the client to be able to display it. We've already checked off this, and this is the part that we are focusing on right now in this module. The code that's required to use Postgres is also incredibly simple because there are special packages set up to use Postgres with Node. You can see here we're using a package called PG, which is a npm package and enables us to set up and get running with Postgres in our Node backend relatively easily. So let's run through this code just so you can get an overview of how you might interact with Postgres from your Node backend. The first thing we do is we create a constant called db, and this is going to contain all of the details that we need to connect to our Postgres database. You can imagine the Postgres database as a server of its own. Previously, we saw that we had a server for an API backend. We had another server for a website that was going to use the API backend, and we had two servers running simultaneously on localhost 3000, localhost 4000. Well, now in this case, you can imagine your database running on its own database server. And this can be local, as will be in our case, running Postgres on our own computer, or it can be hosted on the internet in the cloud in a remote location. But either way, in order to connect to the database, we need some details to verify ourselves. The username, the host, the database name, the password for the database, and the port on your local computer where that database server is running. We're going to go through these parts later when we actually create our database in Postgres, but just know that these are like the username and the password to be able to authenticate yourself with the Postgres database and also connect to the correct database that you actually want to store your data to. Now, once we've added all of those details into our constant, then we can use the connect method that comes from the Postgres package to connect to our database, and then we can use db.query. So we're going to be using db.query a lot because it is where most of our work is done. And inside this method, what we can do is we can write SQL code. So notice how this is being entered as a string, but what's in between the double quotes is what we're already familiar with, which is SQL, so structured query language. And we already saw how we can use this and also what maybe this line of code means. Select everything from the users table. So essentially, we're going to get all of the records from the users table. If there were any errors, then we can handle that. Otherwise, we're going to console log and output all of the rows, so all of the users from this user table. And then finally, we close our connection with db-end, and that is all it takes to start using Postgres with our Node backend. We're going to go into this in detail, and we're going to be doing this many, many times. Don't worry. This is just an introduction for you to get a taste of how we can use Postgres using our Node and Express backends. And just to know that it is so commonly used, and there are all of these helpful methods to make our lives easier and work with this powerful database. As I showed you earlier, this is the npm package that we're going to be using, node-postgres, and it's known as PG on npm. We're going to be installing it, and it will help us vastly simplify all of the operations we need to do with our Postgres database. And you can see by the number of weekly downloads that it is very, very heavily leaned upon by developers. So we are doing all of the right things that professional developers do. In order to get started, the first thing we're going to need to do is to install two pieces of software. The first is the Postgres server. This is what's actually going to stand up a Postgres server on our local computer. Of course, if you're working with a remote server, then you wouldn't need this. But in our case, we do need to run this on our computer, so we don't need to pay for storage costs and all of that. Now, the second piece of software we're going to install is something called pgadmin. And this is a UI or a user interface for us to be able to tap into our Postgres server. Because otherwise, we'd have to be running terminal commands, we'd have to connect to our Postgres server using the command line. And by using pgadmin, we vastly simplify it, and we're able to view and organize and query our data in a graphical user interface. So these are the two things we need to install. And if you head over to the next lesson, you'll see the instructions for how to download and install these pieces of software on your computer system. So for all of that and more, I'll see you on the next lesson. Hey guys.
And that means databases. In the
When we learned about SQL, we looked at how to create tables using the SQL language. Well, this time, let's take a look at some of the specifics when it comes to creating tables using Postgres. By now, you should be pretty familiar with the idea of tables. We have tables where there are the vertical parts, which are our individual columns. So imagine a Roman building with lots of columns. They are always vertical, holding up the entire table. And of course, the columns represent different fields. For example, there's a field called name, there's a field called age, and we can keep adding more and more of these fields. And they're different characteristics of the data that we want to capture. For example, in this case, I am building a table of friends because, of course, as programmers, we don't have that many friends, so it's good to track them in a spreadsheet. Now, if you're somebody who has lots of friends, then you'll have an even greater need to track your friends in a database. And if you think this is completely ridiculous, don't worry, this is just an example for us to learn databases and tables. Now, the other aspect of the table is the row. So these are
Guys, sampai sini dulu. Pusing cok. Mau mati anjir. Oke, berarti kita udah sampai ke database. Dan database itu sebenarnya aku udah nonton kemarin. Jadi bakal aku kayak cuman ngingat-ngingat dikit aja palingan. Jadi bisa lah pas nontonnya. Ah, dan aku nanti juga mau cari info gimana cara hosting web dengan cara hosting gratis dengan website dinamis. Udah dinamis kan ini jatuhnya. Kalau kemarin kan masih statis kan website aku. Nantilah kita cari caranya. Oke, sekian dulu deh. Udah berapa lama nih? 4 hours and 27 minutes and 15 seconds. Oke guys, dadah.